Alright, welcome back. Don't have a PowerPoint today because the pen that I've been using to write on the PowerPoints, I broke yesterday over the weekend. So I'm hoping I
Oh,
can pick another one up at some point either today or tomorrow,
mm-hmm,
depending on when classes end today. But because of that, I'm going to be typing everything out today, so it might take a little bit longer. We'll see.
mm-hmm.
Um, Calc 1 ended up being about the same. Okay, so our objective today is to combine principles of kinematics and energy to predict motion before and after a collision. So I've got our FRQ this time from 2004. This is question 1. And then you'll have the rest of the FRQ from 2004 for homework.
Mm-hmm.
Okay, so we've got um, a rope of length L that is attached to support at point C. Can you see the picture, or is it too small?
I can see the picture.
Okay, cool. There's a mass of M1, which is sitting at the ledge at position A, and then he's swinging down from the ledge to position B on a lower ledge, where there's a mass of mass 2 at rest. At B, the person grabs hold of the object and then lets go of the rope. The person and the object land together in the lake at point D, where there is a vertical distance L between position B and the water. So same length as the rope. Air resistance and mass of the rope are negligible. I want you to derive expressions in terms of each of, in terms of the following variables: M1, M2, L, and G. So everything that we do has to be in terms of those 4 variables.
Mm-hmm.
Okay, firstly, I want the speed of the object, speed of the person rather, so first object, just before the collision with the second object.
So that's conservation of energy.
Conservation of energy, okay, perfect. So I need an energy statement then. What could we say?
Mm, it is conservation of energy.
Okay, so at the start, what type of energy do we have?
Mm. Potential energy is converted to kinetic energy.
Okay, so potential gravitational energy should be equal to our kinetic energy.
Mm-hmm.
I'm going to subscript that as B for kinetic energy at point B.
Mm-hmm.
Okay, so then what's my gravitational potential energy?
M1 GL
M1GL
is equal to 1/2 G1 V square.
is equal to 1/2. Um, okay, say that one more time. 1/2.
M1 V square.
Okay, M1V squared, perfect. Okay, and then we need to solve for, I'm going to subscript that V again. This is velocity at point B, because I'm going to have a lot of velocities in a second. V sub B squared. Weird. Okay, there we go. So if I want to solve for the velocity at B, what do I have to do?
So times 2, we cancel out each mass. So it's V is 2GL.
Okay, so V is root 2GL at B. That's capital B. I need to change this one too. Stay consistent. Okay. Looks good.
Mm-hmm.
Then I need the tension of the rope just before we collide with the object.
Mm. So this one, tension minus weight is equal to MA.
Okay. I'll be a little bit more specific, but tension minus your weight is fine. So I'm going to call that mg. Which m?
M1.
m1g should equal m1 times what?
8.
What is our acceleration?
Oh, centripetal.
Centripetal acceleration. Okay, so you're right, this will equal ma. If I was going to do that, then I would subscript this as maybe net. And then that will end up being our centripetal acceleration as well. So I'm going to subscript that as AC, and we'll sub for AC. What's our formula for centripetal acceleration that we could use?
V squared over R.
V squared over R. Okay, what is R in this case?
L.
Right. V squared over L. Okay, and we are solving for the tension. So what do I have to do?
We just add M1G both sides.
M1G to both sides. Okay. Am I done, or do I have more to do? Are we done, or do we have more to do?
We're done.
Okay, so I would be done, except we have to have every expression in terms of M1, M2, L, and G. And right now we've got an extra variable. So I can't have a V in my equation.
We subscribe V.
Substitute V, okay. So this V is VB right now. So I can sub in for that.
Yep.
So our tension is equal to M sub 1G plus M sub 1 of our V squared, where V is root 2GL. Okay, so what's going to happen there? Oops, it's 2, not a 1. Okay.
So L cancels out.
The L will cancel, okay.
So 2G.
2G.
Oh wait, we forgot M. Yeah, M.
M sub 1G. Okay, that looks good.
So it's 3M1G.
Perfect. Three M sub 1G. All right. Then I need the speed of the person and the object just after the collision.
Conservation of momentum.
Conservation of momentum. How can I set it up? So for momentum before and momentum after they collide.
So before is M1 VB this time.
Okay.
This is equal to M1 plus M2 B final.
Okay. Sounds good. So we'll have M1 V sub B maybe is equal to M1 plus M2 times V sub B0 maybe for B final. Not sure exactly how we should subscript that, but that looks okay to me. Okay, and we are solving for the speed just after. So I want to solve for VB naught. Okay, what do I have to do?
So M1 root GL is equal to M1 plus M2.
M1 times, say again?
Root 2GL.
Root 2GL, okay. Square root 2GL. Over
M1 plus M2.
okay, is equal to V sub B naught.
Mm-hmm.
Okay. That's fine. And I think we can leave it like that, right? So that's M1, M2, GL. M1, M2, GL. Yeah, okay. So we should be fine to leave it like that.
Mm-hmm.
Okay. Part D. I want to know the ratio of the kinetic energy of the person-object system before the collision to the kinetic energy after the collision. So we'll just get those kinetic energies individually, I guess.
So before the collision, that's M1, no, half M1 VB squared.
1/2 m VB squared. And then we'll need to substitute for that VB.
Mm-hmm.
Okay, is 1/2, oops, I need to subscript that m too. That's m is m1. Okay. 1/2 m1, and then what was VB again?
Wait, isn't it? Oh, wait. It should be 2GL if it's square.
Yes. Okay, so we plugged it in and squared it. So what does that simplify to?
M1GL.
M1GL. Okay, perfect. Then we need a kinetic energy after the collision, which I think I marked K sub B naught last time. Okay, so kinetic energy after the collision should be equal to what?
Half M1 plus M2 V naught square.
VB naught squared. Okay, and I'll need to sub for that VB naught as well.
Mm-hmm.
So that's
So
one.
if we square it, um, um, one M1 plus M2 will be cancelled out.
So one of them will cancel.
Mm-hmm.
Okay, let me zoom out here. Need myself a little bit more space. Okay. So you said one of these is going to cancel. So I'm going to be left with what?
Have no, actually two will cancel. So it's like M1 square, 2GL,
Okay, that 2 is going to cancel, like you said.
L
Okay, so
over M1 plus M2.
okay. And then we were looking for the ratio of which way? Before the collision to energy after collision. So I'm looking for the ratio of KB over KB naught.
Mm-hmm.
Okay, so we'll just divide those. KB over KB naught is equal to KB M1GL over KB naught. Okay, is there anything that can simplify?
M1, M1GL.
Okay, so I can flip and multiply, and that m1 GL will cancel from both sides. So what am I left with?
M1 over M1 plus M.
Close. If I'm dividing by a fraction, I can flip and multiply?
Oh. M1 plus M2 over M1.
Okay. I'll turn you up a bit. Say one more time, please.
M1 plus M2 over M1.
M1 plus M2 over M1. Okay, that looks good. Is that all we need? Yeah, just the ratio. Okay. And we are in terms of M1, M2, L, and G, so we're good. Last one, I want total horizontal displacement of the person from position A until the person lands in the water at point D. So that means we're solving for X here in the picture. Okay, total horizontal displacement. What would I have to do?
So so we have to find the horizontal distance from A to D.
So I have to split this up into probably A, B, B, D, right?
Yeah.
Okay, let's focus on BD first. How can you get the horizontal distance that this object will fall before it hits the ground?
1/2 GT squared is
Yeah.
equal to
Okay. So we can say your height at any time. Actually, we can look at it the opposite. So how far you've fallen so far is equal to 1/2 GT squared. And then how far we've fallen at the time we want when we hit the ground is going to be equal to L. Okay, I'm going to subscript this first because the calculus in me is going crazy. So this is our distance that we've fallen so far. Okay, and then we'll set that equal to the distance L to figure out what time we would hit the water. Okay, so I can use this to get a time, and then what do I do to that time?
Horizontal distance is time v times time.
Cool. So our horizontal velocity times time. Okay, so let's solve for time first.
Time is root 2L over G. Very quadrant.
2L over G. Oh. Try it again. Square roots of 2L over G. I want the G inside the root. There we go. Okay, so I've got a time. And then we need our we need our horizontal velocity. Because our horizontal velocity times time will give us our displacement. So this will be x from point B to D is equal to our velocity at B naught times time. Is what you told me. Okay, so I need to sub for VB naught. which we said is this one.
We plug in.
I'm going to plug in. Okay, VBDs or V after is this one. XBD is equal to our VB naught times our time Okay, can anything simplify?
Root G.
Okay, the root g's will cancel. What else?
2.
What's happening?
Root 2 becomes 2, and then it's L, so it's M1 2 L over M1 plus M2.
Okay, that's good. So that's our displacement from BD. Okay, then I need a displacement from AD. Let me go up. What's our horizontal displacement from A to B?
L. Oh, it's given. Yes.
Awesome. Okay, so I
So
could
we just
say
add, L. Yeah.
XAB is equal to L, so that was given. And then we can add it to get our total displacement. So displacement from A to D is equal to displacement AB plus displacement BD, and we'll add them together. Okay, first displacement plus our second displacement of L. Okay, so let's simplify this a bit.
Can we just leave it like that?
I'm not sure. Let's simplify it anyways. So if I'm going to make this into one fraction, what do I do?
So we have to multiply by M1 plus M2.
Okay, so that's going to give me, all of this will be over M1 plus M2. On top I would have my original term, 2M1L, plus L times M1 plus M2. Okay, what's going to happen on top?
2M1L plus M1L plus M2L.
Okay, which simplifies to...
We can simplify from... Oh, that's 3M1L plus M2L.
Okay, cool. And I think that's as far as we go.
Yes.
Did we answer everything for E? Total horizontal displacement. Yep, that was good. Okay, let's see how we did. Scoring guidelines, problem 1. Let's see if I can get this on the same page so we can score each other really quick.
Mr. Brandon,
Yes.
is AP Calculus mock exam due tomorrow?
Yes, but tomorrow at midnight.
Okay.
So I know it's a little bit longer. So that gave you 4 days total to complete it. Okay, so first one, any statement for conservation of energy is 1 point. Okay, so we've got that. And then correct answer, root 2GL is 1 point. Got that. So that's 2 points out of 2.
Yeah.
Then any indication that there are two forces acting on the person, tension and gravity. Okay, that's 1 point. An indication that the acceleration is centripetal, v squared over L, that's good. Correct application of Newton's second law, so that the tension minus weight should equal a non-zero acceleration. Okay, that's good. And then substitution for VB from part 1. That's good. Okay, so that's 4 points. Then any statement conservation of momentum looks good. Correct application of conservation of momentum with a clear indication that both masses have a common final velocity. Okay, we did that. And then answer m1 over m1 plus m2 root GL, root 2GL. Oh, that is a 2. Okay, cool. So that's 3 points. Then, next page. 2 points, 1 point for correct expression of kinematic energy before and after the collision using answers to part A and C. 1, K before M1 GL, okay. K after M1 squared over M1 plus M2 GL, yep, okay, so we got that. 1 point for constructing the ratio from valid expressions of kinematic energy. It does not need to be simplified, but if it is, the algebra needs to be correct. Ooh. So that means if we simplify it incorrectly, we lose our point. But that's okay because we did simplify correctly. Okay. Then correct expression of relating the falling distance to the time it takes to fall from the water. L equals 1/2 GT squared at any point. Yes. Indicating horizontal displacement is the velocity after multiplied by time. Okay, got that. Correctly substituting to solve for t. Got that. Indicating total horizontal displacement is xbd plus L. Got that. Here. Okay. And that's 4 points. And I believe that's everything. So a total of 15. And we're good.
Mm-hmm.
All right. Any questions on anything?
Nope.
Cool. So again, homework's going to be the rest of those 2004 FRQ. Thank you very much for coming, and let me know if you've got any questions on WeChat.
Wait, but there is no homework in WeChat yet.
Not yet. I need to post.
Oh, okay.
So let me do that really quick. Okay. I will see you tomorrow.
See you.